Welcome back to Fire Alarm Fever. Today I will be explaining how a fire alarm system works, starting from the panel all the way to the resistors. So let's get right into the video. You might or might not know that the main power source and basically the home base of the whole fire alarm system is the panel. My panel is the Firewatch 411 UDAC fire alarm communicator by Firelight, but there are very wide amount of panels. The panel I have here is a conventional panel, and we will just be going over conventional systems. So let's go ahead and start with the panel. First of all, of course the panel has to get power somewhere, and there are two ways that the panel can get power. First of all, which you kind of really do need, you have this main power source, which this is just a, it's an electrical cord cut, or a, extension cord cut, and then you can see if I move this mess out of the way, it's plugged right in right there. Now, if the power is to go out in a, say there was a emergency situation, all the power on your street has gone out, we of course need a backup way. And that is where batteries come in. You can see in my panel I just have one battery, and this battery will last up to 33 hours. And it'll run all the devices, and in the case that a smoke or a pull station is pulled, the battery will give backup power. Now, here's the extension cord. You can see it goes into the 120 volt right there, and I'll explain power in a bit. In the case that we still do have power, you can see AC power, then the battery will sit there, and if you have a rechargeable one, it will recharge. Of course, the devices need power also. You can see we have many wires going out to numerous devices. So this is the main part where the power goes in, but through the system is not running 120 volts. My panel actually runs 12 volts. So it goes through the converter and comes up to the zones. So I have a 4-zone panel, and these first zone, the second zone, and the fourth zone are a resistor zone, and zone 3 is a loop zone. So first let's get started with the resistor ones. You can see right here is a resistor, and the reason we have resistors is these are end of line resistors. So you take your resistor, and let's say this was the last device. This is not the last device in my system, but if it was, I would put the resistor on the side of the, you put the wires in the positive and negative, and then there's the other two sides of it. So you have to put the end of line resistor in the other parts so it is not touching the wire. And the reason we actually have resistors is, say we have power and everything, and someone is to come up and cut this wire. The panel would then go into trouble, alerting you of a trouble in the system. On my panel, I have zone 1 as smoke detectors, and zone 2 as the pull stations. So now I'm going to go ahead and explain zone 3. Zone 3 is a special type, and it's called a loop system. And you do need more wire, but it does have its advantages. So on my panel, you take the B plus and the B minus, you take the A plus and the A minus, and you run that to your device, go through all your devices as normal. But instead of putting a resistor on the last device, you will take two wires and bring it back to the panel and put it in B plus and B minus. Now you're probably thinking, why do we need to do that if resistors basically do the same thing. Well, let's say because I have multiple devices on my NAC circuit, which I will get into soon. You can see I go to multiple devices. And let's say that, so this wire goes down to the living room. Say something was to happen to this wire right here, cut. Now, none of the devices other than this one is receiving power. So in the case of an emergency, the only device that would sound is this one. And obviously that's not very useful. But with a loop system, the panel will take power from the B plus and the B minus and run it backwards back into the devices so that the other ones will be powered. Of course, you still do need to replace that wire, and probably if it is in a public system, you're probably going to make sure that your wire is not exposed. But yeah, so that's why we have loops. As I said earlier, the NAC part is the part that goes out into the, these are called notification appliances. And the NAC is a notification appliance circuit. So I have one NAC on this panel, and it is right here. And you can see NAC. And I have a positive and a negative wire going out to my alarms. And so you're probably watching this because you are getting a panel soon, or you need help with a panel. And basically, I've known a few people that have tried to put NACs into zones, which does not work. That's the reason we have NACs. So make sure that whenever you are wiring up your system, that you use the NAC and not a zone for your alarms. So relays are pretty cool. Relays, for my use, I'm about to use it for a door alarm. Now mine actually don't work, so there is a new one coming in. But here's the relay. So you can see we have two relays, and on relay 1 we have no, NC, and C. Relay 2 for the same. Now, relay 1 has normally open, that stands for no, NC for normally closed, C for common, and same for relay 2. Now, let's say if I was to wire up a door alarm, or a door holder, I would take, it's a bit complicated, but here's our 12-volt reset. I would run the 12-volt reset positive over to the common, and the 12-volt negative reset to the common on the door holder, and then the relay 1 normally closed onto the 12-volt, because I have a 12-volt panel. Now, it is normally closed, which means there's always power to it. And once the system goes into alarm, it's no longer normally closed, and now it's open, which will release the power, and it will close the door. You can see there is all of this surrounding stuff around the panel. Now, the majority of the time, you will never have to mess with any of this. I'm talking about all these internal stuff right here. All this stuff is the part that actually runs the panel itself. And unless you need to do some dip switches on your panel, you should never touch it unless you are familiar with it and you have done your research. This is the, I guess you could say, control panel part of the panel. There are, all panels, controls panels, looks different. But you can see mine here is not as common as others. I have a reset button, a acknowledge and silence button, which is both in the same one. So, let's say the pull station is pulled. The system goes into alarm, and then the panel will send out power to the NAC. And if I actually, right here I have my multimeter. If I go ahead and take this and put the positive on the positive part of hold on. You can see I have the positive on the positive part and the negative on the negative part. And you can see on the multimeter, we are reading negative. And the reason we're reading negative is because there is currently no power to it. And yeah. Now, if I was to go ahead and pull this, you would see that jump up to somewhere around 12 volts. But I'm unable to do that at this time. Going back to the control panel, you can see we have AC power, which has a green light next to it. This means it is receiving power. Now, there's, of course, alarm, which will turn on if there's an alarm. Next, we have COM fail, battery fault system, trouble, and supervisory. Now, supervisory should come on if you have a wire cut, or a wire has fallen out of a device, or anything, and the end-of-line resistor tells the panel that. Now, if you have a system trouble on, it could be a lot of things, but the main reason in a home system is because you don't have an end-of-line resistor on. Battery fault means you don't have a battery, or your battery is not installed correctly. And then COM fail, which I'm not too familiar with, but more than likely you shouldn't have to be worrying about it. Now that we've looked at the brains of the system, of course, this is not the only part of a fire alarm system. There are the alarms that go off, and of course there are pull stations and smoke detectors. On my system, I have BG12s and BG8s. You can see. And the way that these work is when you push in and pull down, it's essentially flipping a switch. So, it's basically just a super fancy light switch. If you go ahead and open it with the key, sorry, wrong key. If we go ahead and put our key in and open this up, you can see we have this switch right here. If I was to put this switch down, the panel will detect that and put the panel into alarm, which sends power to the NAC, which sends power to the devices. You can see there's the switch. Now, in the back of the device, there are two terminals. There's one right here and one right here. This one's positive and this one is negative. Obviously, this is on the back of it, so you cannot see it. And so I have the two wires coming from zone 1 down into there, and the positive wire goes in positive, positive goes in negative. Now, on the other side of the screw, I have another wire going into that, which then goes out over to my next device. So, once we pull that, of course we have the things that sound. You can see right up here, this is one of my notification appliances. And, of course, it receives power and it goes off. Now, let's say everyone's sleeping or there's no one at the building. That's where smoke detectors come in. Smoke detectors detect smoke, of course. Now, the way that these work is when smoke starts to accumulate, it will go into the sides of this, and inside of those chambers, it will detect the smoke, and after it goes through verification, it will talk to the panel and tell the panel, you need to go into alarm. Now, my smoke detector right here actually beeps if this device goes off. Now, if I regularly pull it, it will not beep. There are also heat detectors, which there are multiple heat detectors. There's rate of rise, fixed, and the way rate of rise is the majority of the time, if it goes up 15 degrees a minute, it will sound the alarm. The way fixed ones work, there is a specific temperature, and if the temperature goes over that in the building and it detects it, it will put the panel into alarm. I hope you guys enjoyed the very basic parts of the panel or the system. If you guys need any extra help with wiring, wondering about your panel or anything, feel free to comment down below. I will make sure to check my comments as soon as I can and reply to all of you guys. Thank you guys so much for watching today's video, and I hope you all have an amazing day. Bye.